In this video, I'm going to dive into some of the nitty-gritty problems I have to solve to be able to get to the next stage of prototyping. I am manufacturing electric motors here in Australia. I'll be starting with a 2306. That's a little racing FPV drone motor, but I just need to start with the aim to finish. I don't mind a smaller motor, and I like the byproduct being able to benefit a budding industry in Australia. So right now, as we speak, I have to make sure that the teeth on the motor shaft are easy enough to machine. Right now there's way too many and it's way too complex, so I have to reduce the number. I have the link to a website that will actually have a tooth calculator that can tell me everything I need. So we're going to be exploring that in a second, and I'm going to try to explain it simply as I work it out myself, because I'm shit at math, so I'm going to have to make this process simple. Another thing I'd like to point out before I dive into it, the design of the motor has been simplified to make prototyping and manufacturing easy. Some people will say that the top of it looks a little bit too weak and it's not going to be the strongest, and they will be right. Alright, let's dive into some calculations. First, the maximum bending tooth stress. This website, which is the engineering toolbox, and we scroll all the way down until we find titanium. So we have 730. Well, I've got 730 right there. Base width of the gear, we can actually just reference the design for that. We can go over here for the diametral pitch. So this is the pitch of the circle that is on each end of a tooth. Once we've figured that out, we can go back here and we need the Lewis factor. We can either use this website here. The second way is we can actually just use this table. This is a lot easier, but I like to actually cross-check my information. Right here, we need the beam strength of gear teeth. We can actually figure this out by going over to this calculator. Just before we figured out the module, we figured out the face of gear tooth. We figured out the Lewis form factor as per this table right here. The bending stress of gear is what we collected from this one right here. And then we can put in that information to be able to get the beam strength of the gear tooth. So that means that we can come over here and we can insert the information and we can double check the Lewis form factor. So we can see that a Lewis form factor is 0.016. Maximum transmitted load on teeth with all of these calculations is 0.0046. This then has to be divided by the amount of teeth. We'll go ahead and do that and we'll come up with the answer. Maximum transmitted load divided by the teeth is right here, 0.000028125. We can actually cross-check the numbers to make sure that we are not losing too much performance. Not only will the new shaft be simpler and easier to machine, but it's also going to be 411% stronger than the original teeth. So we've both been able to improve the design and simplify it. That's what we want. The simplest plan for manufacturing involves outsourcing the processes required. This would involve getting the electric steel laser cut to size, then punched and finally interlocked. The base, bell and shaft would be CNC machined, and the magnets temporarily outsourced from overseas. And then finally I can get the stators wound robotically for accuracy. This will be okay for the prototyping stage. For us to be able to get to a cost-effective price point, we have to be able to control the individual price of each part, which means that we will need funding to be able to get the machines to be able to manufacture in-house. Another thing that's worth noting is as soon as the equipment is bought, then there's nothing stopping us from providing motors for the EV market as well. It isn't as hard as initially thought. There just has to be a company that is dedicated to putting the logistics together. Now, I was going to start a crowdfunding campaign, but I don't have it in me just yet. I want to keep trying to get private investment first because there will be interested parties. I will provide updates to this project regularly on Vikingr Industries. So I'll cut my rant short there. Bye for now, and I'll catch you next time.